Hello and welcome. I am Dr. Anil Joshi. Welcome you to my series Learn Radiology with Dr. Anil Joshi. In this series, we have covered a lot of topics, right from radio physics, then MRI physics, ultrasound physics, then applications of it. Our website gives it in extensive detail. What are the topics of radio diagnosis we have covered? All are there on our website. Do visit it. But today's topic is, as far as the radio physics is concerned, by and large, it is considered bit difficult by many of the radiology students and many of the technicians. But in a way, we are going to make it simplified today. You realize that it is not at all difficult. So let's get going to the production of X-rays. Then what is really important here is what happens at the atomic level. That interaction at atomic level is responsible for the production of X-rays. Now, heat producing collisions are occurring, then electron displacement is occurring, some displacement in the K-L shells are occurring, some kinetic energy is getting transferred, and some photons are getting realized. That's all in detail we are going to see how the X-rays are produced. Now, first what we have said is the heat producing collision. Now here we are seeing two charts. There are two diagrams in which we are showing a incoming electron and a deflected electron. How they differs? Now let's see. The incoming electron is deflected by the tungsten electron cloud, and a small loss of energy occur. That is heat is concerned. Now there are multiple effects what are occurring. We have seen about it, the X-ray production, but heat production is topic of this particular segment or this part of this lecture. So here incoming electron is deflected by the tungsten, and that causes a small energy loss because that is not of use. So it is in that form of heat. Now incoming electron collides and disappears in outer shell tungsten and electron cloud. That can also happen. This is first displaced. It displaces the peripheral shell, then the excitation of the displayed atom from the ionization occurs. So these are the things occurring. Now X-ray producing collision. First we have seen is the heat producing. Ultimately energy is going to be converted into two. One thing is the X-ray energy and second is the heat energy. Now heat energy we have seen, now we will go to the X-ray energy. Now continuous spectrum. Now here we have to have a breaking radiation, that is Bremsstrahlung. This is a phenomena which is extensively discussed in some other lecture. So here only we will have a passing remark on it. So there will be a continuous spectrum, there will be a characteristic spectrum, that is the line spectrum, that occurs because of ionization and excitation. So these are the two, but there are more also which we have discussed in some different lectures. Now let's go to the Bremsstrahlung radiation. Now sudden stopping, that is deceleration, showing high speed electron into the tungsten nuclei. What we have seen just now, there we have seen it can disappear and produce two effects. Now once it goes into the tungsten nuclei in the target, it produces Bremsstrahlung radiation and heat also. These are the two effects, out of which heat we have seen already. Now here we are seeing Bremsstrahlung. Now this is a breaking radiation. In Germany the word means same. Now here what happens is a kinetic energy of electron is transferred into a single X-ray photon. So it is transfer of energy, some into the heat and remaining into the X-ray photon. Photon is a pocket of energy. Now energy of resulting photon numerically is equal to the energy of electron. Now this is the conservation of energy. Of the two type, direct hit and nuclear means interactions are the two interactions, depending on where the high speed electron will hit. Now a brief about Bremsstrahlung radiation, that is a breaking radiation. Here we have shown how an incident electron comes? It comes from the boiled tungsten filament, where it is given acceleration by the potential difference, and this accelerated high speed electron hit the target. And here what is happening, once it hit the target, it can result into the two aspects. One thing is it can hit the nucleus, it can hit the outer shell, and depending on that there will be a radiation. Now second is a characteristic radiation. It contributes only a small fragment of photons in the X-ray beam. They are not much. Incident electron ejects an inner electron from the tungsten target. It causes atom to become ionized. Then electron from the outer orbit attracted to the void deficiency. There will be deficiency because once the outer electron goes off, and that will be filled. Now energy in the form of characteristic radiation is released in this process. Bremsstrahlung and second is characteristic. Two type of radiations we have seen. Now here it is a characteristic radiation. See how it is occurring with the help of diagram. Whatever we discussed just now, whatever I said, is just shown in the diagram. Now let's go in more detail of characteristic radiation. What are K lines? They are important as far as diagnostic importance is concerned, and L lines, they are having too little energy, so they can either cause a fog or blur, and bombarding high-speed electron must have sufficient energy, that is in between at least 70 kVs plus or minus, that is a critical voltage. Otherwise they will not penetrate the tissues and cause the proper contrast. Now what is the summary of the X-ray production collision? Understanding the physics behind the X-ray production is fundamental for every radiologist. The interaction of high-speed electrons with the target material resulting in Bremsstrahlung and characteristic radiation not only defines image quality but also determines patient safety and equipment efficiency. The mastery of these core principles form the bedrock for optimal image practice, accurate diagnosis, and judicious radiation use. It's a potential harmful. Radiation is potentially harmful unless it is used properly and optimally. As we move forwards, let us remember sound knowledge of basic science behind the X-ray empowers us to use more responsibly and effectively in the clinical practice. Good for patient safety, good for the operating people, and good for the radiologist because the images needs to be of good quality. With that, we are coming to the end of this lecture. I thank you for giving me your kind attention. Do visit our website for more detail. If you like, give us a like, share or subscribe our channel. With this, I am Dr. Anil Joshi logging off till we meet next time in next video very shortly, very soon. Till then, goodbye, good luck and take care.